Hi, this is Jack in the training department, and we're back for another episode of Teardown Tuesday. This particular Tuesday, we're going to take a look at this gas valve. And I don't know what this is from, but it's old, and it came out of somebody's truck stock. It's never been used, but we're going to take a look at it, see how it works, and what it's got going on. It's been sitting in the truck so long that it's rusted. There's no labels, there's no part numbers. It looks like it's probably from maybe a convection oven, but again, it's so old with no part numbers on it that we don't know what it's for. So we're going to tear it down and see how it works. Valves in this style, you see solenoid valves like this used in a lot of gas cooking equipment where you have the regulator built in and the solenoids. So let's start by getting the fittings uncapped, and it looks like it was actually installed at least once because there's a bunch of junk around the fittings. Well, around that fitting. It's only got junk around one side of it, and it is kind of down in the threads there, so it looks like it maybe got installed once and didn't work correctly or didn't fit, so it just got thrown back into the truck stock. A couple interesting things to notice. It's got a screen on the inlet. Down inside here, you can see there's a screen. That keeps any kind of junk, foreign object from getting in there. And it's also got some arrows on it to show us the direction of gas flow. There's another one back here. That tells us which way the gas is moving through the valve. We've got a regulator built in, but there's not a separate regulator vent. It's venting through this little hole right here. So let's start with that. Let's pull that cap off and look at the venting on the regulator. Yeah, so it's going to be really hard to see, but down in the very, very bottom here, there's a very tiny hole all the way down in the very center, down in there. Right in the bottom. And that hole is drilled through to this passage right here. And with the way this cap sits on there, that's being used as a regulator vent. So as the diaphragm inside there moves up and down, it's got to displace the air that's on top here, and it's doing that through that little tiny vented regulator cap. So there's also an adjustment in here for the pressure, so that would be something you would set after the valve was installed. We do have a label on here, and we can see this is a 24 volt valve. It's not specifying if that is AC or DC, but it is saying 60 hertz. And we only have frequency in AC voltage, so we can assume that this is 24 volt AC rated, and then it's got an amp rating of 0.350. So it's saying that this valve will draw 0.35 amp when it's energized. We've also got 3.5 inch down here regulated. So using that 3.5 inch, we know that this is a natural gas valve, because if it were for LP, this would probably be a 7 inch or an 11 inch number. At 3.5 inch, we're working with natural gas. And the other one we've got is a maximum pressure of 1/2 PSI. 1/2 PSI. Now if you remember your conversion from PSI to inches of water column, 1/2 PSI is not very much in PSI, but it is a lot in inches of water column. 1 PSI runs us about 28 inches of water column, so this thing is saying that 14 inches water column is its maximum operating pressure. Given that it's regulating down to 3.5, that's a pretty good range on the natural gas side. But this thing does not work with high pressures. It's a low pressure valve. And then we've also got a couple of numbers on here where it's manufactured, certification agency. This may be the White Rogers valve part number, or it may be this up here. I haven't looked it up to try and figure it out. But either way, we know it's 24 volt AC natural gas valve. So let's get it opened up here, let's see what it is. First thing to notice, there's two different types of fasteners. On this part of the valve, we've got a Phillips screw back here, like a number 2, pretty straightforward. But then we've also got these things. And these things are different, right? They're like a star pattern. but then they've got this pin inside here, down in the center. And those are called a Torx head. So this star pattern is called Torx, T-O-R-X. But because there's a pin down in there, we call it a security Torx. And to get that apart, we're going to need some special tooling. So this is an example of a kit that I carried around in my truck. I had this in my truck for years, that's why the label's all beat up. But all this is star bits, Torx bits, in both solid and hollow. And then this is called an external Torx. Not very common in cooking equipment. See it sometimes in automotive. But when we open this up, it's a bunch of Torx bits. And you can see this particular bit has that star pattern, but is also drilled down through the center to give that pin a place to go in the bit. Set that off to the side, and we'll set that right there. And let's start by pulling out these two Phillips fasteners. And it looks like those are part of the retaining system for the coil themselves. Yep, so this bracket, all this does is hold these coil bodies on. So now that that's off, we can get those out of there. You can see down in there, you can actually see the little bits of copper winding, and I don't know if that'll come apart any further without cutting. It looks like it's probably epoxied together. But down inside there is a winding of real fine copper wire. You can just sort of see it. And it looks like it was injection molded together, so it's going to be hard to get apart. When we energize that winding, that coiled up wire creates a magnetic field, and that pulls a plunger inside of here. So we'll get in a little further and see that. In fact, let's go in that direction next. So we've got to pull out those 3 Torx screws. And the reason that these are set up with security Torx is they are trying to discourage you from opening this valve up. The security Torx is pretty much used only in places that are not serviceable. Anything that they expect to be serviced will be more accessible. And these fasteners are interesting too. They're kind of stamped into a triangular shape, and that means they will self-tap when you run them in. Alright, so we got a retainer plate. And then we've got a cover and our actual plunger. So when this valve is energized, these are the actual plungers that go up and down. And they've got a spring and a diaphragm underneath, or a plunger underneath. You can kind of feel the resistance and see them snapping back. So they're spring loaded. So the magnetic energy from that electrified coil would grab that steel plunger and pull it up. So let's get these other two out and we'll see what else is in here. There's all kinds of stuff going on in here. All right. So we pulled off this top cover, and the first thing that happened was some springs fell out. So this spring here was down inside there. Now we pointed out earlier there's a threaded adjustment here, so let's go ahead and pull that out so you can see what's going on there. As this threaded adjustment is run in and out, it's changing the amount of spring pressure that pushes against this diaphragm. So there you can see the little plastic, and it almost looks like it's been over tightened because it does not have any thread left on it. So these little lines, these are threads, and they're pretty much gone. They've been chewed off, there's not much there, so they just don't have much thread left to work with. This spring underneath is what actually puts pressure onto this diaphragm. So that's what's changing our gas pressure adjustment when you turn this screw in and out. You're changing that spring pressure and that amount of push onto that diaphragm. Here's our plungers. So here's our first plunger, and you can see there's a little seal on the end of it. And here's our second plunger. And we can take a look at the gas pathway through the valve here. There's some milling that's been done down inside this valve. We'll get to that in a second. Let's pull this diaphragm out next. So this diaphragm is a really thin rubber, and it's meant to stay flexible. And then down underneath it is a very small plastic plunger. So let's try and show you before I pop it apart. You can just barely see it down inside there, in case it gets damaged when I pull it apart. Nope, there we go. So there's our diaphragm, and this is just a backing plate that sits on top. And then the plunger itself has actually fallen down inside there, so we'll have to try and dig it out. This is a seal. You can see that seal was just pressed down in there. Yep, and then there's the plunger. So what's going on here is the bottom of this seal and the base of the plunger mate together, so that when that diaphragm pulls all the way to the up position, this creates a seal and closes down. And when you pull that seal out, you have enough space to be able to pop that out of there. All right, so that's it. Let's go through the gas path here. So we have gas coming in, comes in here, moves through this passage and comes up to the bottom of this seal where the plunger was. Depending on the position of that plunger, we're going to get some gas flow through into this side of the body. And there's this opening that's milled into the first solenoid. So the first solenoid would have this plunger pressed down in there, closed. The spring keeps it closed. So the gas reaches this point and cannot go any further until that solenoid is energized. So that first solenoid opens up. The gas can flow down into this passage that's drilled through the bottom of the valve. And once the gas is in this passage, we now have a fitting here that could go to a pilot light or a low flame setting, but it's been capped off in this particular valve. And we can't get any gas through. Oh no, looks like I was wrong there. This is actually closed off down underneath. It hasn't been drilled all the way through. Interesting. So I thought this was a piece of casting, but this is actually a pressed-in plug. They did the machining operation. They drilled this hole and then they pressed this plug in to close it back off again. It does not go all the way through the bottom. So the gas comes in from the regulator side. This plunger lifts and the gas then flows through to this hole and sits on the top side of this other plunger. And it cannot flow out this fitting or this fitting until this plunger lifts. Interesting. Yeah, so you have to have both plungers open to get any gas flow out of this valve. Now if you were going to have a pilot fitting, you could have a standing pilot here, but this is more likely a pressure tap for checking the incoming gas pressure. It'd be more likely you would have a pilot tap here where they've capped it, because you'd have one solenoid to run this side and the other solenoid to run this side or this main outlet. Interesting though. So the only thing that has changed here is how deep they machined this passage underneath. Now, they ran their tooling in about halfway and stopped and left a bridge there to seal the two sides of this from each other. Alright, so that's pretty much it. That's the inside of our solenoid gas valve. Had the regulator and the two solenoids, and we pulled everything apart here and worked through the gas path. So that's how it works. Alright, so we've talked a lot about how the valve works, but now let's talk about how the valve fails. There are 3 or 4 common ways that these valves can fail, and let's go through some of the most common ones. So the first one would be these coils. These coils are very small gauge copper winding. They're very tiny, very thin, and they're made to work at a very specific voltage. So if some condition on the site causes the voltage to spike, you can burn these coils out. And that condition can be a site problem, like a power surge when power blacks out and comes back, or it can be an issue like a component failure further up, like a short in a control transformer. And a short in a control transformer for this, being that it's only made to run at 24 volt, will mean that the spike of voltage to this coil will burn it out. So if either of these coils gets over voltaged, then they're failed. The next most common failure is foreign objects. So inside this valve you can see it's pretty clean because it's never been used, but it's got a lot of precise passages inside it. We've also got a screen on the inlet here. And that screen is really important because if any debris gets down in here, it's going to jam up either the movement of the plungers on this side or the action of the regulator on this side. And that screen prevents debris like tape, pieces of thread tape, from getting into the valve, but it does not prevent oil. And if you are at a location where they are using threaded pipe, they have a pipe threading machine on site, that oil will travel through this screen, and once that oil gets inside the valve, it restricts the motion of all the parts, the regulator diaphragm and the plungers that move up and down over on the other side of the valve. The plungers themselves slide in these sleeves, and if any oil gets in those sleeves, it restricts that motion, that movement, and it means that these plungers will either stick open or stick closed, and that will cause the valve to fail. The next one would be failure of the actual rubber inside the valve. So the ends of these plungers are all a pretty soft rubber, and if they get any kind of oil or grease from the pipe on them, that will cause the rubber to break down, but also age will cause this rubber to break down. The rubber will get hard, and it will no longer be able to create a tight seal against the sealing surfaces inside the valve body. And when that happens, you get leaks through the valve. You'll get burners that candle or don't go out when the valve closes, or you'll get restricted action on the diaphragm for the regulator and inconsistent gas pressure. This regulator diaphragm is very thin, especially on the edges, because it needs to move quickly to respond to changes in flow demand. But that thin material also is very easily damaged. So eventually it will harden up and it will start to split through and crack, and then the regulator won't function correctly anymore. The diaphragm doesn't respond to changes. The last one, and the one that we can actually fix but is easy to miss, is a restriction in this regulator vent. So if you remember at the beginning, we talked about the vent sits on the top of the adjustment screw here, and there's a very, very tiny hole down inside the center of this. If we get any kind of grease or oil on the outside and it makes its way into this opening, we'll no longer be able to move the regulator freely. When the regulator moves up and down in the body and it has to displace air above and below it, it's got to be able to breathe through that vent. If that vent is clogged, the regulator diaphragm locks in place and the valve opens and sends gas to the burner, but the regulator can't increase flow to match that demand, and the burner will poof and light and then immediately go out. And that's a sign that this vent has become clogged. So the easiest way to test it is to just take the vent cap off and see if the system works. If that fixes it, you can clean this vent cap out, but if it doesn't fix it, then you probably have a hardened diaphragm in the regulator that's restricting that motion. So those are the most common ways you'll see this fail. Hi folks, my name is Jack Kell and I'm a Senior Technical Trainer for SmartCare. The video you've just watched is part of a larger series of technical training videos we make available to our technicians at SmartCare. If you found this interesting and you'd like to see more, please subscribe. I'll be releasing a new component teardown video every Tuesday in 2022. If you're already a SmartCare technician and you have a part that you'd like to see me tear down, please reach out to me internally for shipping instructions. If you're not a SmartCare technician, but you or someone you know would like to learn more about a career as a service technician specializing in commercial restaurant equipment, please check out our open positions at www.smartcaresolutions.com/careers. Thanks for watching.